Okay, so for this video, we will be discussing mainly about the domain and range, the concept about the domain and range. All right, and then first of all, of course, we need to understand some important terms where you need to know what is the meaning for function, domain, range, and then we are going to learn one-to-one function later when we cover the part for inverse function. All right, the word of inverse function we'll cover it later as well, and also the composite function. So for this video, we mainly focus for all this domain and range. All right, and after that, we need to identify the range of a given function in the simple cases and also find a composite of two given functions. So the composite function and also the inverse function will be covered maybe in the next few videos. All right. Okay, so for this video, we focus on this one where we need to know what is the meaning of domain and what is the meaning for range. Okay, basically, right, for all the function, it will be expressed in this pattern. And then if you can see that they give you some value of x followed by the equation of the function. So this is what we call as domain. So usually the domain will be stated after the equation of a function is given. And again, what is the meaning for domain? Domain of x is actually the values of x where it is defined. The function is defined. Okay, in the function above, the x is an element of R, or all real x are example of domain. So like what I mentioned just now, this is actually a domain. Okay, and basically for domain, it is the value for x where the function is defined. And if we have a look for the range, right? So the range of function fx is the set of value of y for which the element in the domain map. Okay, function with similar expression may have different domain. Hence, it is possible that the function has different range too. So we will discuss this one by using example 13. Okay, so from the simple introduction on the term domain and range, right? Basically, it's like this. If let's say I'm having a function, okay, let's say this value is 3, let's say this value is 7, and then let's say this value is 4, and this value is 5, let's say lah. Okay, so in a simple case, right, you should know that the domain means where we define the graph or where we define the curve or the line. So if let's say I'm having a section of the line, something like this, and from here you should know that the domain will be actually from 3 until 7, where it actually denotes the value of x that we define the function itself. And for range, you will be looking for the value of y, where in this case you can see that y is actually between 4 until 5. So this is actually my range for the function, and this is actually the domain for my function. So domain, we are looking for the value of x that is defined on the graph, or maybe it is defined in the formula. And after that, we are having the range where you need to decide the range, okay, according to the domain given. Alright, so this is a very simple introduction about the word domain and range here. Okay, then if we proceed further, they said that the function with similar expression may have different domain, and hence it is possible that the function has different range too. Okay, so we'll try to explain this statement by using example 13. Okay, so for example 13, I actually show a few different formula here, a few different functions here for part A, part B, part C, and part D. And if you try to observe these 4 parts, right, these 4 sections here, these 4 parts, okay, we are having all the same equation for the function, or same expression for the function, where you can see that it is all x squared plus 3, x squared plus 3, x squared plus 3, and x squared plus 3. But if you try to have a look for the domain given, right, their domain are different actually, where you are having x can be any element of R. That means this one can be x, can be any number, any real number. X is greater than 0 or equals to 0, x greater than 1, and also x is between -1 until 4, and the 4 is inclusive. Okay, so when the domain are different, although the expression are the same, right, you will try to, you can actually see that the range might be different as well. So how we actually decide the range? So in short, in a more simple way, not so complicated one, we generally can sketch the graph by using the transformation concept that we learned earlier. So as an example, all the x squared plus 3 here, right, all the x squared plus 3 here, the basic function comes from x squared, and then you have a plus 3 outside the basic function, where that means you are moving it 3 units up. Okay, so 3 units up from the original graph, which means if you want to sketch this graph out, basically your graph will be a U shape. Okay, and the minimum point here will be actually a 3 because you are shifting the graph 3 units going up, right, vertically. So this is your function for x squared plus 3. And when you want to sketch this function, we need to actually have a look for the domain as well. They said x can be any real number. That means x can be from negative infinity to positive infinity, which means that my graph can go still to the left, continue to increase, go to the right also, the graph will continue to increase. That means the graph will continue increasing, just I have no space to draw it out. Alright, okay, so after you sketch the diagram by using according to the domain already, then you can decide the range by looking at the diagram. Where is the smallest point, or where is the lowest point for this diagram? So you can see that the lowest point for this diagram is actually this line where it is y equals to 3. And since my graph is going up, right? So that means when the graph is going up, the value will become bigger and bigger. It should be infinity. So from here, you can see that the range for this function, the smallest value is a 3, and the function will keep on going up. Therefore, when I want to write out the range for this function, it should be y greater or equals to 3. Okay, because as what we know, the range means that the value for y, the value for the function y, okay, when the under the given domain. Okay, so you can see clearly from this graph, right? The smallest value here is actually a 3. Okay, then the graph keeps on going up. Therefore, the range when we write it out, it will be y greater equals that to 3. Or you can write fx greater equals to 3 also can. Okay, then maybe now we can further investigate part number B. Okay, so for part number B, right, I'm still having the same expression where it is x squared plus 3. And the domain given is actually x greater equals to 0. Alright, so if I have, if I want to decide for the domain, right, decide for the range. Again, I draw the original curve first. The original curve for x squared plus 3, it is still something like this, where this is a 3. But for this domain, right, they only want us to consider the domain where x greater equals to 0. Therefore, when I want to show the graph, right, I only consider the part where x greater equals to 0. So this is the part where x is greater and equals to 0. That means when I want to look for the range, I only consider this part of my graph. Okay, so you can see that for these two examples here, part 1 and part 2, although the expression are the same, because of domain are different, therefore for this one, I consider the whole graph, but for this one, I only consider half of the graph, where I only want to have the graph where x is greater equals to 0 for this domain. Okay, so after you sketch the graph already, then again, you decide the range from the graph. So what is the smallest value or the lowest point for this graph again? So you can still see that the lowest point is at y equals to 3. And for x greater equals to 0, right, the graph will keeps on going up. The curve will keeps on going up. Therefore, you are having an infinity value again. A very, very large value. Therefore, for this example, the range of the function, it is still the same like part A, where the function should be more than or equals to value 3. Okay, so far for these two examples, right, they are having different domain, but their range are still the same. Although the graph looks slightly different, right, but the range still the same. Okay, so maybe we can proceed further to the next two examples. Okay, so for the next one, we are looking for part C. Still the same expression where x squared plus 3. We are having x squared plus 3, but now we only want to consider the graph where x is greater than 1. Okay, then again, since the expression is still x squared plus 3, right? So when I want to sketch the diagram, it will still looking something like this. It is still a U shape, x squared plus 3, right? Okay, and this value is actually a 3. Okay, then now, because of the domain given here is x greater than 1, Therefore, I want to know if my x value is a 1 here, what is the value for the y? Okay, so what is the value for the y? So how can I decide the value for the y? You need to substitute the 1, okay, into your function. Therefore, you're having 1 square plus 3, which is equals to 4. Okay, that means if I know that this is actually a 4, right? This is a value 4, and this is a 1. When I want to sketch the graph for the domain where x greater equals to 1, that means I only want to consider the part of the graph from here onwards. Okay, from here onwards. So you can see that this is actually x greater than 1. And if I want to sketch out the graph, I only want to consider the graph from this part only. Okay, so my final graph for this particular domain will be something like this. Okay, where you can observe that the value start from 1, and then the lowest value now for the y is actually a 4. So again, to decide for the range, so what is the lowest point? So this is the lowest point here, right? Okay, lowest point for the graph, and therefore your y is actually equals to 4 lah. But actually there's no equal sign here. Why I put the white circle, okay, white small circle, it is because of in the domain, right, they didn't include the 1. But of course, when you want to sketch the diagram, we still substitute the 1 into the function so that I know what is the value here. Okay, and when we want to write out the range, we will refer to this value. That means the lowest point is actually at 4, but it is not included. The value 4 is not included. And then the graph will keeps on going up when x is greater than 1. Therefore, when I want to write out the range, for this case, right, you will have y greater than 4. And there's no equal sign here. Because the domain has no equal sign included, therefore for your range also at this particular value also has no equal sign included. Okay, so now you can try to compare the graph and the range that we have for A, B, and C now. So you can see that for A and B, although their domain are different, okay, but the range are the same. Then when you try to introduce part C, and you realize that now the range are different already compared to part A and part B. So you can see from here, basically when you want to decide the range, right, it will be very good if you can try to imagine the shape of the graph in your mind. Alright, so I draw it out for you here so that you can understand further, okay, how we decide the value of range actually. Okay, so maybe we can have a look for the last one. So for the last one, we're having x squared plus 3, and they determine, or they decide, they fix the domain to be from -1 until 4. -1 of course is not included, and then we're having the 4. Again, you will know that for this diagram, right, the basic shape is still a U shape. Okay, but now before I sketch it, maybe I want to substitute in the value -1 first. So substitute -1 into your function fx, you have -1 squared plus 3, and therefore it is a 4. Then you can substitute in the value 4, and then you're having 4 squared plus 3, which is actually 19. Okay, alright, so you will have your U shape. Okay, so maybe I can draw it like this first. Okay, this is originally a 3, right? Okay, so now from this diagram, I know that when x is equals to -1, this value that I have will be a 4. Okay, and when the value is x is equals to 4, this value here will be actually 19. Okay, so if I want to draw it in a more accurate way, okay, so maybe I emphasize it by using the black color graph. My graph, the domain that I want to consider for this graph is from -1 until 4. I only want to consider this part of the graph. Okay, yeah, so for this particular domain, my graph will look something like this. Okay, then to determine the range. Okay, maybe before we determine the range, just a little bit explanation about the symbol here. You can see again the small white circle. The meaning is it is at -1, but it didn't include the value -1. Not included. There's no equal sign here, right? In the inequality, therefore we put it like this. And then when you're having the equal sign in the inequality, that means the value itself is included. Therefore, usually we'll put the black dot. Okay, so again, now I want to determine my range. So by looking at the diagram here, right, where is my lowest point? So you can see that actually 4 is not my lowest point in the graph, right? My lowest point is actually here. This value is still included, okay, in the diagram. So my lowest point is actually still y equals to 3. And what's the highest point of this particular curve? So my highest point for this particular curve will be this one, where it is y equals to 19. So this is actually the range for my function for this example. Okay, and from here you know that the range of the function will be from 3, then y or fx. Okay, you can write fx, and then 19. Okay, then now the problem comes out for the sign. Okay, the point 19, right, it is at x equals to 4. So for x equals to 4, it is included in the given domain, right? That means the 4 is included. Therefore, when you want to put a sign here, it should be smaller or equals to 19. Okay, then the problem now is for this one. What is the sign that should I put? Should I put smaller, not included, or should I put included with the 3? Smaller, greater included 3. So which one is correct? Okay, then again, you refer back to your graph. When the -1 is not included, right, the value should be at 4. But if you observe from your diagram, the 3 is actually at x equals to 0. And this 3 here basically is included in your graph. Therefore, when you want to write out the symbol here, you need to have a smaller equal sign. Okay, so this is one example to show you that when we are having all the same expression for a function, right, but different domain, the range that we want to find might be different, although the expression is the same. Okay, so this is to me, I think it is a good example to show you that when we are having different domain, okay, then the range, some might be the same, some might be different. All right. And what is the best way for us to actually decide? There are many ways for us to decide the range, but for A-level syllabus, right, for me, I will personally very rely on the graph, because we have learned how to sketch the graph from transformation as well. So it will be quite convenient for us to sketch the graph and then try to imagine the graph. Then we can decide the range from the diagram. Okay, so this is just an introduction about the domain and range for a function. So for we'll discuss more different example on how to decide the range, okay, in the next few videos. All right.